Now we're going to look at some examples of exponential equations that have different bases. There's no way that we can get either side to be the same base. So our steps here, the first thing we've got to do is isolate whatever the base is to the unknown power. So we need to look at the first step to see if you understand what I'm talking about here. This is a base raised to unknown power, and it is by itself. In problem 8, if you'll notice, here's my base to the unknown power, but it is not isolated. So in this problem, I would have to divide both sides by 10. So when I say we've got to make sure our base is isolated, that means it's got to be all by itself on one side. Now once that occurs, then we're going to take the quote-unquote appropriate log of both sides in order to move the unknown power using the power rule. Now our choices are log and ln. If I have a base that's 10, I'll always use log. But if I don't, I always use ln personally because I can write it faster. That's my only reason. And another reason in just a second, and we'll get there in just a bit. And then we have to solve our equation and check. So in this particular problem, since my base raised to the unknown power is already isolated, I'm going to take natural log of both sides. Remember, whatever you do to one side, you got to do to the other. The only reason I'm doing this is so that I can bring the x out to the front using my power rule. So that would be my next step. Now, if you've been working with your log keys, remember when I press natural log of 9, it will give me a real long number, just indicating the exponent that I need to raise e2 to get it. So this is representing a number. So since that number is multiplying my x, I'm going to divide both sides by it. And then I can get an approximation, normally to 4 decimal places. So let's see, I've got natural log of 4 divided by natural log of 9. And that's where I got the 0.6309. Now if I store this value in for x, I can check in my calculator, and me using the whole thing, I should end up with an answer of 4. So 9 raised to the x, and there's my 4. Let's try this one. Now this one I've already talked about. My base raised to unknown power is not isolated. So my first step here is I've got to divide both sides by 10. Now I'm going to take natural log of both sides. Remember, golden rule, whatever you do to one side, you've got to do to the other. So when I bring this exponent out, something happens. Guys, remember, natural log of e, whenever this number is the same as the base, it's equal to 1. That's why I said if I had 10 raised to a power, I'd use log, because the same thing happens. So now this represents a number. Just remember that. So I'm going to solve like I normally do. I'm going to add 7 to both sides. Then divide everything by 3. And let's see, now since the numerator is a binomial, I need parentheses. So natural log 0.5 plus 7. So there's my numerator. Divide by 3. Surrounded to 4 decimal places. So I'm going to store this value in, because you always go back to the original to check. So 10. Let me do my second ln, so I get the e and my caret symbol all at one time. 3x minus 7. And there's my 5. So I put a little check here. That works. So this one, base raised to unknown power, it is isolated. So let's take natural log, or maybe you try log. I just can write it faster. So I'm going to pull out the 2 minus x, but now it's a binomial, so I need to pull it out with parentheses. Now there's a couple of things I could do here. I could distribute this through, and it would not be pretty. Or I could divide both sides by natural log of 5. So if I divide both sides by natural log of 5, now I'm almost done. Could do a couple of things here, but since my x is negative over here, I think I'll add it to this side, and then I'll subtract this term to this side. It's just a little bit quicker. If I just subtract 2, I'm still going to have to change signs of everything. So it's just, whatever you want to do. So let's put this in the calculator. I've got 2 minus natural log of 12. Close that parentheses. Divide by natural log of 5. So let's see if I ended up with 0.4560. Okay. And I'll leave the checking to you. Store it and go and type in your original, and it should come out to be 12. In this one, base is isolated. That's raised to the unknown power. So take natural log or log of both sides. This is sort of similar to that problem we had earlier. I need to bring out this binomial in a parentheses, and I'm going to divide both sides by natural log of 4. If it was a whole number, it'd be a different ball game, but it's not, so I usually just go ahead and, because I know it's a number. Now, I'm wanting to solve for x, so the only other thing I need to do is subtract 3 from both sides. So if you put this in your calculator, you should end up with a negative 1.7075. So you need to try that and see. This one is very similar to the one right up here in that my base raised to unknown power is not isolated. So I need to divide both sides by 1,000. I'm going to specifically take natural log of both sides because I'll be able to get rid of that e in just a second, because now I need to free out my exponent. It comes out, and when I do, it should be 0.09t equals natural log of 5. And we're almost done. All I need to do is divide both sides by 0.09, and then if you put that in your calculator, you would end up with that. Now, before I leave this problem, it should sort of look familiar because this is the PERT formula, my continuous compounding. So my P would be 1,000. Here's E. Interest rate's 0.09, but I don't know time here. Now, what this problem is getting to is I'd like to find out how long it would take 1,000 to grow to 5,000 at 0.09% compounded continuously. It would take 17.88 years, almost 18 years. But it still grows. That's cool. Let's look at this one. Base raised to unknown power. Already isolated. Take natural log of both sides. Bring this out. It's a binomial. Divide natural log of 4 into both sides. Move down a little bit more. So like I did a little bit earlier, I can get x almost by itself, but it would be to my advantage to add x, but subtract that term. So let's see if I did that. And if you put that in your calculator, you should end up with that. Store that. I'll go ahead, I'll store it. I'm not going to store the whole thing because I want you to see what happens. Because I think you should know. So 4 raised to parentheses 1 minus x. Notice it doesn't come right on 5 because we rounded. So this would indicate that I rounded up. Okay? So that's it for this lesson. Thank you.